This lecture segment is about resistance and Ohm's law. The objectives of this segment are to characterize materials as conductors or insulators based on their electrical properties, state and apply Ohm's law to calculate current, voltage, or resistance in an electric circuit involving a single resistor, and demonstrate the use of multimeters, power supplies, and resistors. Let's start out with our pre-assessment questions. Which materials listed below are conductors? Go ahead and record this in your notebook now. Which equation below is incorrect? Go ahead and record your answer in your notebook now. What is the voltage drop across a 50 ohm resistor when a current of 0.10 amperes flows through it? Question 4. What is the current through a 10 ohm resistor when it is connected directly to a 15 volt battery? It should be number 5 even though it says number 4. How do you connect a digital multimeter to measure the voltage across a circuit element? Go ahead and answer these questions now in your notebook. Reviewing the diagram, did you successfully demonstrate the use of multimeters, power supplies, and resistors? Go ahead and answer the question, and I also want you to explain your answers. So if you said yes, I want you to tell me why the answer is yes. If you say no, I want to know why you say no. Here are the physics terms for this video: resistance, resistor, ohm, electrical conductor, electrical insulator. If you're not sure what these terms mean, please make sure that you record them in your notebook with the definition so that you can review it daily. The equation for this video is I equals V divided by R, which is Ohm's law. I is the electrical current in amperes, V is voltage in volts, R is the resistance in ohms. Electricity is all around us, yet we are not electrocuted on a daily basis. Why not? Well, some materials are good electrical conductors, while others are good insulators. Air, plastic, glass, wood, and rubber are all good insulators. A typical electrical wire has copper on the inside and plastic insulation on the outside. Copper is a good conductor because it has many electrons that are free to move through the material. The plastic covering on the wire protects us from getting electrocuted. Ordinary tap water may conduct electricity, which is why you should never use electrical devices or near a bathroom or a shower. This is also why they recommend you not take a shower or wash dishes while there's an electrical storm. So how much current? This lamp conducts electricity. When the lamp is connected to a 10-volt source, 2 amperes of current flows through it. But why? What determines how much current will flow? The lamp itself helps determine the current flow. Is the lamp filament a good conductor, or does it resist the flow of current? It actually resists the flow of current. Some materials are better conductors than others. How do we quantify this difference? Well, we quantify it by calling it electrical resistance, which we use a capital R to represent. It is a measure of how hard it is for electricity to flow through that material. Resistance is measured in ohms, where we use a capital omega, which is a Greek letter, to represent ohms. Electric circuit elements that have resistance are called resistors. Resistors control the flow of the current in a circuit. Light bulbs have resistance too. The symbol for a resistor in a circuit is a zigzag line, which you can see to the right. There's actually 3 different types here. You'll see a resistor. You'll also see what we call a potentiometer, which is a variable resistor. We can actually change the resistance by sliding a metal lead that touches it back and forth. And then we have the lamp. Here's an analogy to resistance. Upside down water bottles are actually similar to resistances or resistors. Small bottle opening means high resistance. We have a small current flow, very little water flows through. Large bottle opening means we have low resistance and we have a very high current flow. Here you can see how a large opening causes the current to flow more quickly. That means more water comes through. If you actually want to see an animated illustration of this, go to page 480 in your online textbook or the one that you've downloaded to your computer. Ohm's law relates electric current to the voltage and the resistance. The current through a resistor will increase if the voltage increases and decrease if the resistance increases. So it's inversely related to the resistance and directly related to the voltage. You must use consistent SI units for these equations. So you can't use milliamps or millivolts or kiloohms. You actually have to convert your units to amperes, volts, and ohms to make sure that this equation is used in a correct manner. Ohm's law is not actually really a law. It's actually a mathematical relationship that closely is obeyed by most conducting materials. The thing is that there are some materials that do not obey Ohm's law, and we'll talk about them as well. There are three ways you can use Ohm's law. You can determine the current by through the resistor by using the voltage and the resistance. You can determine the voltage drop by multiplying the current times the resistance. You can also determine the resistance of the circuit by taking the voltage and dividing it by the current through the circuit. Again, the unit for resistance is the ohm. This form of Ohm's law that you see here can actually help you remember what an ohm is. It's actually a volt divided by an amp. So an ohm is a volt per amp. What is the current through a 10 ohm resistor when a voltage of 5 volts is applied across it? Go ahead and write your answer down in your notebook. We use I equals V divided by R. We take 5 divided by 10, and that gives us 0.5 amperes. Remember, on the AP exam, you have to write the equation, you have to substitute in the numbers with the units, you have to write your answer with the correct number of sig figs and the correct units. So please make sure you've included all three of these steps. On page 480 of your online textbook, there's going to be an icon which you can click. It's an interactive calculator. In your textbook, if you go to this page, there'll actually be the questions that you can actually practice with. If you want to get a feel for how changing the resistance or changing the voltage will change the current, you might want to go ahead and do that, because a lot of times you may find that that's what they do on these AP exams. They may say, if I put two resistors of the same value, what happens to the current? What if I take one of the resistors away? What happens? Okay, so by looking at the numbers, it might help you prep yourself for that. I'm not going to go through it in this lecture, but you can go ahead and do that on your own time. I just wanted to make you aware of it. Okay, you'll probably not see this on the AP exam, but it is actually kind of interesting and necessary actually in the class in order for you to be able to look at resistors that are in the bag and be able to determine their resistances. So there are colored bands. There should be 3 colored bands that give you the value of the resistance, and then the last one should be your tolerance. Okay, so you're going to use 2 digits and then a multiplication factor. So the third band tells you what to multiply by. So the first band, you look at the color and it tells you the value. The second band tells you the color. You look at the color and it tells you the number. And then the multiplier tells you what you multiply by. So for instance, if we look at the first, the example at the top, they have red. Red is number 2. The next band looks black, and that's a 0, so that's 2, 0. Then it says brown, so that's 10 ohms. That's your multiplier, okay? So most likely this is a 20 ohm resistor, a 200 ohm resistor, okay? So that's how you determine the resistance using the colored bands. So let's go through this investigation. For part 1, the current through different resistors. For part 1, number 1, find a 100 ohm resistor by reading the resistor color code. Construct the circuit on the breadboard. Power it using a plus 3 volt power supply or 2 D-cell batteries. Number 2, connect an ammeter in series with the resistor. Measure the current through the resistor. Repeat the experiment for at least 4 other resistors between 50 ohms and 2 kiloohms, which is 2000 ohms. Tabulate your results for R and I and calculate 1 over R in each case. You're going to graph the current on the vertical axis and you're going to graph R on the horizontal axis. Describe the relationship between current and resistance for a fixed voltage. You're going to make a second graph where you plot I on the vertical axis and 1 over R on the horizontal axis. You're going to fit a straight line to your data. So in other words, find a line of best fit. What is the slope of your graph? Record that in your notebook. What does the slope represent? Record that in your notebook. You're going to replace the resistor with a lamp. Measure the current through the illuminated lamp. Calculate the resistance of the lamp using Ohm's law. Record that number in your notebook. What is the resistance of the lamp? Imagine you have a complicated circuit containing many resistors. How can you use Ohm's law to find the resistance of the entire circuit? Write down what you think now in your lab notebook. Or when you do this in class, write it down in your lab notebook. In the investigation, you're going to use a digital multimeter to measure the current and the voltage. If a multimeter is not available, you will be using the voltage probe and the current probe with the LabQuest. Resistance can also be measured directly with some types of multimeters. You'll have to check the multimeter in the lab to see if this is possible. If it is possible, you're going to set your setting to ohms, and then you're going to go ahead and disconnect the resistor from your circuit, connect the positive and negative lead of your multimeter to either side, and you should get a reading of your resistance. So let's review what we've learned. Which materials below listed are conductors? Go ahead and write down in your notebook all of them that are conductors. Hopefully you've written down that the answers were aluminum, copper, and gold. Which equation below is incorrect? Go ahead and record it in your notebook. The incorrect equation is B. What is the voltage drop across a 50 ohm resistor when a current of 0.1 amperes flows through it? Go ahead and pause the video and record your answer in your notebook. Using Ohm's law, we write V equals IR. We take the current of 0.1 amps, multiply it by 50 ohms, and we get 5 volts. What is the current through a 10 ohm resistor when it is connected directly to a 15 volt battery? We take I is equal to V over R. 15 divided by 10 is equal to 1.5 amperes. How do you connect a digital multimeter to measure the voltage across a circuit element? You're going to connect the multimeter in parallel with the circuit element in order to measure the voltage across it. You're using the multimeter as a voltmeter. For the last question, did you successfully demonstrate the use of multimeters, power supplies, and resistors? Yes, you are learning some of the basic skills that all electrical engineers need to know. And also those of you that need to pass the AP Physics 2 exam. If you have any questions about this video series, please let me know. Write down your questions in your notebook and make sure you ask me tomorrow in class.